This is Mr. Ashton going through the Mathematics Unit 2 Calculator Allowed higher tier paper from the summer of 2017. Okay then, I'm going to skip straight to question 12 because the first 11 questions have been done in the intermediate paper. So if you need access to any of the first 11 questions, click the link below and it'll take you to the intermediate paper where you need to just look at the last 11 questions. Okay then, so the question for question 12, the first one on the higher only paper, said, can you make C the subject of the formula? To make C the subject of the formula means you want to get C all by itself, all on one side. So what I need to do is start to carefully unlock this to get C by itself. So the first thing I'm going to do is get rid of this whole side here being divided by D. I'm going to bring it round to the other side. I'm going to get C minus 5, which is two things, so I'm going to have to keep them in a bracket, times by D. That's going to give me 3C minus 7 alone there, okay? The next thing I'm going to do is expand out a bracket. Can't leave it all within a bracket. I'm going to have to expand it out, start trying to get the C by itself. To get DC minus 5D is equal to 3C minus 7. Now I can start getting the C's by itself and everything else onto one side. So I'm going to bring this minus 3 over to this side because it's got a C in it, but at the same time, I'm going to take anything that doesn't have a C over to the other side. So I'm now going to have DC. That 3C will become a minus 3C here. That minus 5D will become a plus 5D, so just 5D, and minus 7 on this side. So now I've got everything with C on one side, everything else with everything else on the other. But this isn't just C's alone. I want that C by itself. I just want there to be one C. So the way I'm going to do that is factorise. I'm going to take C out as a factor to get D minus 3 here, which is 2 bits, is equal to 5D minus 7. And that C is times in by that bracket, so I'll take that to the other side, and I will divide by that bracket. Now, there's actually no need to keep that in a bracket. I can leave it without, but if you prefer to keep it in, you can as well. Okay? On to the other side, it says, question 13, first by calculating the size of BAC, so I need to go and work out this angle here, calculate the area of triangle ABC. Now, they've given us a really good, clear sort of way of how to tackle this. They could have just said, work out the area of this triangle. Now, because this is a higher tier paper calculator and a non-right angle, this will be using from your formula sheet, which mine is here. It will be using this formula here, a half AB sine C. Now, if you go and look where side A and side B is, and the angle they meet at, C, that's no coincidence. You look at two sides that feed in together to meet at an angle. So if we've got this triangle here, we look at the two sides that we're given, so this side here and this side here. I need to know what that angle is there. However, they've told me to go and work out what BAC is. So they want me to go and work out the one that I highlighted before. Now, the reason why they want me to do that is because opposite that angle, I know this side, and this angle here, I know that side. So that's setting me up to use the sine rule, okay? Now, to use the sine rule, I'm going to put the angles on the top, so I'm going to say sine angle A over little a would be equal to sine angle B, so sine 46, over the side little b, so over 5.3. I now want to get A by itself, so the first thing I'm going to do is I'm going to times by sine, so the sine 46 over 5.3, I'm going to times that by 6.4, as it's dividing on this side here. And then I'm going to take the sine over to do inverse sine of that. That will tell me what angle A is. Okay, so into my calculator, shift sine, fraction, 6.4, sine 46, close your bracket, over 5.3. Bracket doesn't go there, it needs to come all the way over to the side. Equals 60.3 blah, blah, blah. Okay, now that's this angle here, 60.3 blah, blah, blah. I need to know what this angle here is. So angles in a triangle add up to 180 degrees. So I'm going to say 60.3. Now I'm going to say to one decimal place for that so far. However, I'm going to try and be really accurate. In fact, actually, look at that answer there, because to one decimal place that is ludicrously close. I'm going to stick with that, saying it's 60.3. But usually, further into the paper, I'll be keeping that in my calculator as ands. So I'm going to say angle C, so BCA, will be equal to 180, take away the 46, take away the 60.3. 180, take away 46 take away 60.3 tells you this angle is 73.7 degrees. So now I know what this angle here is. I can use the area is equal to a half of the two sides that feed into it. So a half of 6.4 times by 5.3 times by a half AB sine C. So sine 73.7. And that will tell me what the area is. Okay. So it's going to be a half. So 0.5, 6.4, 5.3, and then sine 73.7, close bracket, to get 16.27, so 16.3 centimetres squared to one decimal place. Okay, question 15. I've already seen it jumping out at me in bold letters. It says, these sides are measured to the correct nearest centimetre. Now, I haven't even read the question. I can already tell you it's on upper and lower bounds. Now, because all of these measurements are correct to the nearest centimetre, I'm going to go and work out the upper and the lower bound of each of these lengths, okay? So, the upper and lower bound I would find by working out, it says the nearest centimetre, which is the nearest 1 centimetre, half it is half a centimetre. You take it off to find the lower, so 30.5. You add it on to find the upper, so 30.5 here, 20.5, 31.5. Here, the upper bound would be 13.5, lower bound would be 12.5. Here, upper bound would be 23.5, lower bound would be 22.5. Okay, just cross that out and make sure it's really nice and clear, 23.5. Okay, then it says work out the greatest possible area. Well, to work out the greatest area, got to try and think about what circumstances would do that. It would be the biggest big rectangle, so biggest big area, take away the smallest small area. Smallest small area. Okay, now in order to work out the biggest big area, that is going to be the longest length times by the longest width. So it'll be 31.5 times by 22.5, no, 23.5. Take away the smallest length of the white triangle, so 20.5, take away times by 12.5, and that will give me the greatest shaded area. Okay, so into my calculator goes 31.5 times 23.5, take away 20.5 times by 12.5, which gives me an answer of 484 centimetres squared. Okay then, so question 15 asks about a transformation. Now, if you've got to page 16 and it's asking about transformations, there's only one that's going to be on a higher tier paper, and that is going to be a negative enlargement. Okay, negative enlargement. So I could already get 1 mark for saying that it's an enlargement already. What I need to do is find out how I've gone from A to B. So I need to find its centre of enlargement. So what you do is you look for corresponding vertex. So this one here, so it's the bottom right of this corner here, would be the equivalent as this one here, and you join them up with a ruler. You need to find at least one other point. So I'm going to choose the one above it, which will effectively be the one below it there, and join those two up as well. Now, as you can see, where those two have crossed, that is telling me what my centre of enlargement would be. Now, if I found another vertex, so here to here, let's use this one up here, the same as that one there. If I join those two up, look, it goes through the same centre again, okay? So, I now know that it is an enlargement. That's 1 mark. The centre is where those lines cross, so that is 7, 4. And this is where my final mark comes in. That's the worst set of coordinates I've given, 7, 4. There we go. And the scale factor is equal to, now I know it's a negative because of the way it's flipped it round. And you look for corresponding sides. So from A to B, let's look at that side there. That is 4 squares divided by 2. 4 divided by 2 because we're going from A onto B. So 4 divided by 2. Hang on. No. I'm lying. That hasn't got twice as big. 4 divided by 2 is 2. That's got smaller, so it shouldn't be It shouldn't be 4 divided by 2. It should be what the new one is divided by what the original one is. So it should be minus 2 over 4. So the scale factor is minus a half. Okay, so each of these statements here will get us the mark. Okay, question 16. It says, the table below shows the 3-day rain forecast from Monday, Tuesday, Wednesday in Eglisuru. Day, Monday, Tuesday, Wednesday, probability of rain. It then says, calculate the probability that it will rain on all 3 days. So we're looking for the probability of rain, then rain, then rain again. Okay, so we do the probability of rain multiplied by the probability of rain, multiplied by the probability of rain. 0.8 times 0.8 times 0.8 is 0.512. Okay, put it into your calculator to check if you want. You could do 0.8 cubed. That is 0.512. We're then asked down here, it says, calculate the probability that it will rain on exactly 2 consecutive days. So this is all about knowing how to write this out and get your head around it. Rather than doing probability trees, it's going to make more work than we need to. Chance that it's going to rain on 2 consecutive days. So I get rain on the first day, then rain on the second day, but then the third day, I don't want rain again. It's only raining on 2, so I'm going to put R bar, okay, which just means not that it's going to rain, okay? Now, to work that out, I'm going to do 0.8, chance that it rains, times by the chance that it rains, times by chance that it doesn't rain on this day, which is 0.2. Is there another combination that could have got me 2 consecutive days of rain? Well, yes, so that it didn't rain on the first day, and then it rains, and then it rains again, okay? And that would be 0.2 times by 0.8 times by 0.8, okay? Is there another combination? Well, I could have probability that it rains, then that it doesn't rain, then it rains, but that doesn't follow that they're consecutive days. So that is the only 2 combinations that work. I'll put that into my calculator and work out what that is. So 0.8 times 0.8 times 0.2 comes to 0.128. This will also be the same. You could, in effect, just say, well, there's only 2 combinations, so it's 2 lots of that answer. And 0.128 times by 0.128, we add those together to work out what the total probability of that happening is. So the answer is 0.256. Okay, question 18 is all about knowing what the minus means. The minus means that you literally have 1 over. That's what the minus means. Okay, then you just treat it like a normal fractional indice. The denominator tells you that it is to the 5th root of w, and then you put a bracket around that and you put it to the power of the numerator. So we're looking for whichever one is that, this one here. Okay. Okay, question 18 says solve this equation. Give your answer to 2 decimal places. And the fact they're telling me that it's going to be 2 decimal places, the fact that I'm on a calculator paper is telling me to go and use the quadratic formula. I'm expecting to use minus b plus or minus b squared minus 4ac all over 2a, which is given on the second page of the formula sheet. Now, to do that, that needs to be a quadratic. At the moment, it is not. So I need to try and find x by itself. The first thing I don't like is this denominator. So I'm going to times the other side by the denominator. And because there's 2 things here, I'm going to bring both of them over, rather like we did in question 12 where we moved it down there. Okay, so we have 5x minus 3 coming over together as a bracket is equal to 7. I'm then going to expand that out. So the x is going to times both of those to get 5x squared minus 3x. To get it as a quadratic, I need to bring that plus 7 over. So it's now a minus 7 and it's equal to nothing. Now, I should be able to go back, if I go and have a look at the formula sheet quickly. Can you see here where it says the quadratic equation? It's got to be in the form that it's something x squared plus something x plus c, so plus something is equal to nothing, okay? And that's the formula that I've quoted, okay? Now, to go and work that out, I'm going to write down my page here. A equals B equals C equals. A is the number in front of the x squared, so just 5, that should be 5x squared. B is the next number including the sign, so minus 3. And then C is the next number, so minus 7. Then it says minus B, so I'm going to put minus brackets plus minus square root brackets squared minus 4 brackets brackets all over 2 brackets. All I'm doing is changing the letters to open brackets to begin with. Now, we're told the first letter is B, B is minus 3, that's what's going in there. The next letter is also B, so minus 3 is going in there. So let's add those 2 bits in so far. So minus 3, minus 3. Okay, the next letter is A, so 5 is going there, and 5 is also going there. So A, there, and then the final bracket that's empty was minus 7, which was C. So minus 7 goes in there, which is C, C, C there. Okay, now I put this into my calculator, but I haven't got a plus minus button. The way that you do that is you just choose one first, and then you get two answers, and then you choose the other one second. So I'm going to put minus brackets minus 3. I'm going to go plus first, square root brackets minus 3 squared. Oh, I haven't finished yet, so there we go. Minus 3 squared. Where's the cursor? Minus 4 brackets 5. New brackets minus 7, close brackets, all over 2 brackets 5, okay? So literally that thing there, I've written in exactly the same way. I've just chose the plus sign first. And then I get this answer. So I press SD, and to 2 decimal places, when I use the plus, x equals 1.52 to 2 decimal places. And then I will choose the minus this time. So rather than writing out the whole thing again, I press the replay button. I go to the front of the equation, delete the plus, change it to a minus, press SD, and I got minus x equals minus 0. Okay, have a quick read of the question. I'll go through it in 5-10 seconds. Okay, 19A says, give one example to show that the square of an irrational number is not always rational. If you do not know what a rational number is, or you do not know what an irrational number is, Google it now, pause the video, get your head around what it is. I can explain very, very briefly what it is here. This is how I always remember it. A rational number is an integer divided by an integer, okay? It is one whole number divided by another whole number. So any whole number is always rational, okay? So 5 is rational because it's 5 over 1. 10 is rational because it's 10 over 1, okay? Any whole number is always rational. Any fraction that we know is always rational. So a half is rational. A third is rational. That means 0.5 is rational. And it also means 0.3 recurring is rational as well. Okay, because I can write it as 0.3 recurring can be written as 1 over 3, which is an integer over an integer. An irrational number is a never-ending, never repeating number. Okay, never-ending, never repeating. Okay, so a couple of numbers that I think of for examples all the time when I think of irrational numbers would be pi. That's never-ending, never repeating. And the square root of a non-square. So, for instance, the square root of any number that's not a square number, so the square root of 5, cube root of any cube root of, say, 11. They're both non-cube numbers. Also, square root of 2, all of those would be irrational numbers. So if I go and put in, for instance, the square root of 2, and I press SD, it's never ending, it's never repeating. Okay? It then says, give one example to show that the square of an irrational number is not always rational. Now, if I did the square root of 2 squared, that would be rational because the square root of 2 times by itself would cancel out the square root. So I can't use the square root of a non-square, but I could use the cube root of a non-cube, or I could use pi and pi squared. I'm going to use that one, okay? So pi and then pi squared, okay? Now, what I could do is say 3.14 here, and then if I put pi squared there into my calculator, I'm going to say equals 9.86, blah, blah, blah. Okay. Part B says find two different irrational numbers that answer to make the calculation below rational. Now, if I come back to the root 2 squared business, I said that would be rational. That's absolutely true. And the real reason what's going on here is that if you do root 2 times by root 2, I don't quite know, I put those in brackets, effectively, you times the numbers within the squares together, and the square root of 4 is 2, rather than like the proper mathematical way. So what I'm thinking of is getting the square root of a square number. So let's just pick any square number you want, but make it an even one. If you make it an odd one, you'll find it very hard to find any other numbers that make it. So I'm going to do 36. So I'm looking for two numbers that times together to give me 36. So 18 and 2. Now, neither of those are square numbers, so they would both fit in there. Okay, the square root of 36 is 6, so that would work. Give me any other pair of numbers that times together to give me 36. You could have not root 6 times root 6 because they're the same, but root 9 times root 4. No, you couldn't use those because the square root of 4 is 2, the square root of 9 is 3, square root of 6 is square root of 36 is 6, but these aren't irrational numbers. These are rational numbers because really root 4 is 2 and root 9 is that. So that one doesn't work, it's wrong. Any others do it? Root 12 times root 3, that would also work. And equally, you could have a different square number. So think of a different square number that's even, let's say 16, root 8 times root 2, that would do it as well. Okay, think of a different square number, say 64, root 32 times root 2. All of those work. Okay, so I've given you loads and loads and loads there. Go with my first one, root 18 times root 2 is equal to 6. Okay, it's equal to root 36, which in turn is 6. Okay, over the page. Okay, so this is a double spread. I'll try and show you both there. Now, this is really looking for you to understand your transformation of graphs, which is a tricky topic and is seen again at A level. It says the sketch of the graph y equals f of x is shown below. The two specific points are shown on the graph. They're called the maximum and minimum points. So this is the maximum point here because it's the highest that graph reaches, apart from the bit where it goes up and just carries on to infinity. And this bit here is the minimum point before it sort of goes all the way down there, okay? Now, it then says the graphs on the opposite page are transformations of this graph here, okay? Draw a line connecting these. So I need to connect these graphs. Now, I'm just going to go literally one by one here. This graph here to here has literally just been flipped. Can you see there that that is the mirror image of that? So I'm looking for one with the minus f of x, which is this one here, okay? So if it's ever been flipped in a mirror image, it will have a minus in front of the f of x, okay? Next one underneath they've actually done for us. They've told us that one there. This one here is this graph, but it's been moved down 2 places. So if it's been moved down 2 places, I'm looking to see f of x alone and then separately a minus 2. So this one up here, okay? This one here has been moved. It's moved this graph over to the right 2 places. If it's moved to the right 2 places, I'm looking inside a bracket, not a plus 2 like I'd expect, but the opposite. So I'm looking inside a bracket for minus 2, which is this one down here. And then this one here has been stretched. It's now twice as big, so I'm looking to see a 2. The y coordinates are twice as big as they were originally, so I'm looking to see a 2 in front of the f of x, which would be this one here. Okay? Tricky question, that one there. You need to know all your facts of transformations of graphs really, really thoroughly to be good at that one. Okay, and we're on to the very last question now. So the very last question says, the cube has the internal diagonal of 20 centimeters, which we can see there. The edge of the cube is the length x. Okay, so x is there, x is also here, okay? It then says, calculate the value of x. You must use an algebraic method, show you're working. Now, what they're looking for you to understand is that there's lots of right angles going on within here, okay? Now, the first one I'm going to point out using a pencil is this one here, okay? Now, there's a right angle triangle at the base of this cube inside it, which is here to here to here. That's a right angle triangle, okay? Now, there's also another right angle triangle, which is this length here, the same length that I just highlighted in yellow, so I won't go over it. This one here, and the 20 is also a right angle triangle. That's what you're expected to be able to see here, okay? Now, to work this out, that is the hypotenuse there that we're given. We know this side here, but we don't know this yellow side here, okay? Now, to work that out, look at the base. We've got a right angle triangle where we've got 2 of the sides, which are x's. So I can say that x squared plus x squared must be equal to what I'm going to call this is, I'm going to call this h for hypotenuse, is equal to h squared, okay? X squared plus x squared is 2x squared, and that's equal to h squared. Now, what I would do ordinarily is that I would square root that, but I know the square root of 2 isn't a very nice number. I could, if I wanted to go and write 2x squared is equal to h here, but in some respects, but this will help me as much as this will help me. In fact, the top one will help me even more. Now, the reason why that will help me is if I come to this statement here, the pink right angle triangle, I know the hypotenuse, so I want to do 20 squared, take away one of the other sides squared, so let's say take away x squared, would give me h squared, okay? This h squared here, okay? Now 20 squared is 400, x squared I can't do anything with, but h squared, I've already stated that h squared is equal to 2x squared. Okay, so I'm going to say it's equal to 2x squared there. What I could do is I could say it's equal to the root of 2x squared, all squared, and they cancel out. Okay, but I'm going to jump up to that statement there. The next thing I'm going to do is add x squared onto both sides to get 400 is equal to 3x squared. I'm now going to divide both sides by 3 to get 400 over 3 is equal to x squared. And then finally, I'm going to square root 400 over 3 to find out the value of x, and that will tell me what that is. So if I do 400 over 3, find out what that is, square root of that answer, I will get the answer x equals 11.5 centimetres to 1 decimal place. Okay, hopefully that was useful. If it was, please hit the subscribe button and have access to any more videos as and when I release them. Thanks for watching.